Hello, welcome back to Algebra. The title of this lesson is Conic Sections, Circles, Part 2. So we're just continuing in the sequence of understanding more and more about what circles are. In the last lesson, we introduced the concept of the equation of a circle, and we drew a bunch of sketches of what those circles look like. We also derived what the equation of a circle is. But I was also careful to tell you in the middle of all of that stuff that a circle really isn't a function. And I know that kind of blows people's mind at first because you think functions are the most important thing, and then a circle obviously isn't a function, and it seems like really weird. So what we're going to do here is we're going to investigate that a little bit more. We're going to dissect why a circle isn't a function, draw some pictures, and we're going to show you how you can split the graph of a circle up into two different hemispheres, the top hemisphere and also the bottom hemisphere. Each hemisphere can be a function, but the whole thing as a unit will fail the vertical line test and will not be a function. So just learning a little bit more about the concept of circles here. So we all know that all circles, every circle that you could possibly plot has the form of the following equation. X minus some number h squared plus y minus some number k squared is equal to some radius squared. When you put in h and k, that's the center of where the circle is. The radius lives on the right-hand side. You square that. This thing we have said time and again is actually what the equation of every circle is. But we've also said in passing that circles are not functions. Let's talk about why. So let's talk about a parabola, something that we have graphed a lot. We're actually going to talk a lot more about parabolas as well. It turns out parabolas are conic sections also. So anyway, we're going to draw a little bit of a parabola here. Now, the parabola, I could draw it right here at the origin. I could draw it down here. I could draw it up here. I could draw it upside down if I want, because we all know we can play around with what the parabola looks like. But let's just draw a simple parabola up here just to kind of get it out of the way. Now, when we say something is a function, what does that mean? We talked about functions in the past. What is a function? A function is a very specific definition. It just means there's a one-to-one correspondence between the inputs and the outputs. Remember, a function is a box. A function is like a mathematical box. You don't really know what's in the box. There's some calculation going on inside the box. There could be chipmunks or monkeys or squirrels inside the box doing the calculation, but whatever. Inputs come into the box, calculation is made, outputs come out. But a function is a special case where for every input we put in, there's only one output. Only one output. And that's what we mean by a one-to-one correspondence. You see, the inputs are listed along the x-axis here. These are the values that go into the function. And then some calculation is done, and then the outputs come out, and that's what we plot on the y-axis. So you see, for this value of the input, there's only one value that comes on the output. On this value of the input, x is equal to 2, out comes a single output. X is equal to 1, out comes a single output. X is equal to 1, 2, 3, 4, 5, 6, and then out comes a single output. You see, no matter what value I pick to put in, I always just get one output back. That's what a function is. Now, to write that down, we say each input, which we call values of x, gives only one output, which we call values of y, or f of x, right? Now, in a lot of books, we talk about the vertical line test. Vertical line test is a quick way to figure out if this is true. If you can draw vertical lines and they only hit your graph in one location, then the thing is a function, because if it only hits in one location, that means that every input only gives you one output, which is the definition of a function. So this thing passes the vertical line test. So we